Okay, welcome back. Right now we're going to be working on Unit 4, Lesson 2. And what this lesson is about is ultimately taking standard form and then learning this new method called completing the square, which is taking that standard form and turning it into vertex form. And that vertex form is important for us because ultimately it gives us the vertex and we can sketch it out pretty quickly and find a lot of important information from it. So these are going to be our steps for completing the square. So the first thing that we're going to do is start off with standard form. So that's what you see right here, this 2x squared plus 12x minus 3. And then our first step is going to be to factor out the coefficient in front of the x squared. So what that's saying is, take this 2, or whatever this is, I don't care what this is, a negative sign, negative 300, it doesn't matter what this value is in front of the x squared, it needs to be divided out from the first two terms only. Do not touch the last term. Leave it. Okay? Because what we're ultimately doing is going to be making a perfect square trinomial here. So what that means is we're going to divide out the 2 from the first two terms, so then we're going to be left with x squared plus 6x. That negative 3 still remains. So that's the first step, to factor out that 2 from the first two terms. The next step is that we're going to take this middle number, this positive 6, and we're going to do two things with this positive 6. We're first going to divide it by 2. 6 divided by 2 is 3. Then we're going to take that value, that 3, and we're going to square it. So 3 to the power of 2 is 9. Now we can't actually change an equation. So when we add a 9 to our equation to make it a perfect square trinomial, we're also going to minus a 9. Because 9 minus 9 is 0. So this would cancel out. So we're not actually changing the equation. So that's our little trick around that. Our next step is that we're going to take that number, the negative number, out. But in order for us to take it out of the bracket, to put it with the final constant at the end, we have to multiply it by whatever we've taken out of the bracket. So 2 times negative 9 is negative 18, and now it can come out of the bracket. We're going to group like terms together, negative 18 minus 3, and then we're going to factor x squared plus 6x plus 9, which we're going to use sum and product for. But now there's going to be a trick that I'm going to teach you, because ultimately we're making a perfect square trinomial. So when it comes time to factoring, we don't need to spend all this work doing sum and product and making our chart. But ultimately the two numbers that multiply to give you 9 and add to give you 6 are 3. They're both 3. So 3 times 3 is 9, 3 plus 3 is 6. So it's x plus 3, x plus 3, and there's 2 of them. That's why we have a square there. Again, we're making a perfect square trinomial. We'll group the last two terms together, the negative 18 and the 3, and now we've got our final form at the bottom here, which is vertex form. So this is kind of outlining and showing you the steps. The only way to really understand this is to practice this on our own. So let's look at the first example here. We've got y equals x squared minus 10x plus 6. The number that's in front is a positive 1. That's our leading coefficient in front of the x squared. I don't care what that is, take it out. So that means divide it by the first two terms. So I'm going to take that 1 out of the x squared minus 10x. Now, is that 1 actually going to change anything? No. But I'm just showing you this step so that you can understand that it's being done, even though it's not actually having an impact. The next step is going to be to take this middle number and divide it by 2. That's the first part. That's part A. Then part B, 10 divided by 2 is 5. Don't worry about the sign. Because ultimately you're putting the positive and negative version of that number in anyways. Now you're going to take that 5, and part B, the second step, is to square it. And this is going to make our perfect square. So 5 to the power of 2 is 25. This number, we're going to add and subtract it into our equation. So we're going to get 1 bracket x squared minus 10x plus 25 minus 25. That 25 comes from here. And then that positive 6, bring it down. Nothing is ever happening to this 6. It just keeps being brought down, that final constant. Now you're always going to take the negative 25 out. So in order to take it out, we have to multiply it by the number that's in front of our bracket to get it out of the bracket, to break the bracket. So 1 times negative 25 is negative 25. And now it's outside my bracket, which can be added to the 6. And now we're going to ultimately factor this expression in the middle. Now if I factored it, if I did sum and product, and I spent all this time here of negative 10 and positive 25, and I fine-tune numbers, and it ends up being 5 times 5, well, 5 times 5 is positive, but it's not a negative, but negative 5 times negative 5 is positive 25, and negative 5 plus negative 5 is negative 10. So then I would write down x minus 5, which are 2x minus 5s. So then I would write x minus 5 squared. Now to save all that work, we don't have to do this. We don't have to do sum and product because we made what we're factoring. So we know that it's a perfect square trinomial. So here's the shortcut of what we're going to do. We're going to square root our first term, which is x. We're going to take the sign of the sum, and we're going to square root our last number and write that in. And look at that. It ends up being the same thing that we solved for when we did sum and product, but we don't need to. And then the final number there, negative 25 plus 6 is negative 19. And we're done. We know what our vertex is. 5 and 19, negative 19. Be careful, that negative now becomes a positive when you take it out for your vertex, which is your x and y, or your h and k. Now let's keep going and look at another example here. B. You've got negative x squared minus 14x plus 1. What's the first rule, or first step? Take out whatever number is in front of the x squared out of the first 2 terms only. You're not going to touch that last number. It's going to be brought down in every step. So let's look at the first coefficient there is a negative 1. That's going to be divided out of both of those terms. So here it is. I've taken it out. And now inside my bracket, negative 1 divided by negative 1 is positive 1. Negative 14 divided by negative 1 is positive 14. That's step 1. Step 2. You take that middle number and you do 2 things to it. You divide it in half, and then you square it. And then this number is the number that you're going to add and subtract in at the end. It's actually, completing the square is not that many steps. So x squared plus 14x plus 49 minus 49. Now what number am I going to take out? The positive 49 or the negative 49? That's right, you're going to take out the negative 49. But before you can take it out, you have to multiply it by the number that's in front to break the bracket. Negative 1 times negative 49 is positive 49. And now we're going to factor our perfect square trinomial, and we're going to do it the quick way. the square root of the first term, the sine of the sum, the square root of the last term. Put it to the power of 2 because there's going to be 2 of them. 49 plus 1. What's my vertex? -7, +50. So that's called completing the square. That's all we're doing. We keep doing the same thing over and over and over again. Now here's where you have to be careful. Don't think of the first step. This is what a lot of students get confused with. They think about this first step of factoring out that coefficient and they think they have to factor. They think it has to be a whole number or that it has to be a, I don't know, greatest common factor, perfect square trinomial. It's not that. It's just you have to get rid of it. So it doesn't matter what it is, it's got to come out. So let's look at another example here. I've got y equals 2x squared plus 8x plus 5. The number that has to come out of the first two terms is whatever is in the front, which is a 2, a positive 2. I don't care what it is, it's coming out. There it is. The 2 is coming out. Now it's at the front. So now that we've taken it out, we're left with 2 divided by 2. We're left with 1x squared. 8 divided by 2, we're left with 4x. Cool? That's the first step. Second step, 2 things happen. You take 4 and you divide it by 2, which is 2. Take 2, put it to the power of 2, which is 4. So now in our new equation, we're going to add a 4 and we're going to subtract a 4. The negative will come out. Before the negative can come out, it has to be multiplied by the gatekeeper. So then we're going to be left with 2 times 4, or sorry, -4, which ends up being -8. And now we've reached the final stage where we can factor 2, square root, sine, square root, -8 plus 5, -3. Our vertex is -2 and -3. Now here's another good example here. Y equals -1/2 x squared plus 2x plus 20. Now we don't really like using fractions, so I'm going to write it as a decimal here to make our lives easier. Remember, we can always do that. Now the first number that's in front is a -0.5. Again, it does not matter what it is. It's coming out. So here's that -0.5. Goodbye. It's on the outside now. We got rid of it because we're trying to make something called a perfect square. So then we're going to be left with -0.5 divided by -0.5. We're left with x squared. 2 divided by -0.5 is -4x. We're going to do the same things that we did to that 4 on the other side over here. So 4 divided by 2 to the power of 2 is also 4. I don't think I need to write down that step. So we're going to add a 4 and subtract a 4. We're going to multiply 0.5 by -4 to take it out. So half of -4 multiplied, -0.5 multiplied by -4 is now +2. We'll complete our factoring quickly. Square root, sine, square root. And add the last 2 numbers together. That's completing the square. That's ultimately what we've gotten to in this unit, is that we're now able to not only factor and turn something into factored form from standard form, but now we know this method of completing the square to be able to take standard form and turn it into vertex form, which is a very useful form. So now in this lesson, and really in this unit, the only word problems that we're going to be dealing with is when I give you something in standard form, and all you're going to need to do is complete the square and then tell me the information from that vertex. So let's look at an example. The Canadian Opera Company's profit on this production is modeled by this equation that's given to you here. X is the cost of tickets. According to the model, what should the company charge per ticket to make the maximum profit? So that this is a profit equation. So at the end, we're going to have a vertex, and the price of that vertex is the X value, and the amount of money that we're going to be making is the Y value, that max value from that vertex. Because ultimately what you're looking at is something like this, right? It's a graph, it's a quadratic equation. It should be a negative. Let's make sure that it is a negative here. Oh, yeah, it is a negative. It's got to be pointed down for these profit equations. And there's going to be this high point right here that's called a vertex. That high point has an X and a Y value, which is that vertex. And X is the number of tickets that need to be sold in order to produce the maximum profit. So we're going to find out that number and how much money we end up making, which is going to be my H and my K value. Okay, so all we're going to do is take that equation and we're going to complete the square, because then that's what's going to give me my H and my K. So let's write down that equation. And the first thing that we're going to do is take out that negative 40 out of the first two terms. I don't care if it goes in evenly into 8,800. Hopefully it does, but if it doesn't, if there's a decimal, cool, doesn't really matter. It's got to come out. So 8,080 divided by negative 40. Well, it's a positive, so it's negative 220. Now we're dealing with some big numbers here, but it doesn't really matter. What we're going to do to that 220 is we're going to divide it. So it's going to become 110. 110 to the power of 2 is going to become 12,100. Now we're going to add a 12,100, and we're going to subtract a 12,100 into our equation. And of course, that number at the end doesn't go anywhere. And now we're going to take out the negative 12,100, but we're going to have to first multiply it by that negative 40. Well, that's going to be another big number there. So negative and a negative, it should be a positive. So we're looking at positive 12,100 times 40, 484,000 minus that 33,400. Now I'm realizing a mistake that I did here. I forgot the 0 at the end. So I'm going to have to carry down that 0 that I forgot. It's no big deal. There it is. But now it's not 33,000. It's actually 334,000. So I'll group these two numbers together. I'll use my method of factoring, of squaring, sign in the sum, and then square root. So we'll be left with negative 40 x minus 110 squared. Then take those two numbers and subtract it. Should get 150,000. So what this is telling me, when I take this out, this H is my 110, and this 150,000 is my K value. That this is the X. This is my Y. So this is telling me that I need to sell According to this model, what should the company charge per ticket to make the maximum profit? Well, the price per ticket should be $110. And how much money are they going to end up making if they charge everybody $110? They should be making $150,000 on that production. So then you would write yourself a therefore statement. Therefore, the price per ticket should be that $110 to reach a maximum profit. Now looking at this next example here, it's saying you want to build a fence around 3 sides of your front yard. Cool, 3 sides of the front yard. The function 60x minus 2x squared. I don't like that already by looking at it. I can think to myself that there's something wrong there. Represents the area to be enclosed. X is the width of the yard in meters. Write the equation in vertex form. Determine the maximum area that can be enclosed. Okay. Well, if I'm looking at this equation that's given to me, it's in the wrong order. Okay, so they're trying to trick you here by putting the 60x in front of your negative 2x squared. It should be the other way around. So what I'm first going to do is rearrange my formula into negative 2x squared plus 60x. Now it's from greatest degree to least, and now I can take out that negative 2 that I know is the first step when I complete the square. If you're wondering what's at the end here, it's just a 0. So if you want to write a 0, go ahead. But my first 2 terms, just like the beginning of completing the square up here, that negative 40, all I did was take the negative 40 out of the first 2 terms and left this number at the end and carried it down. That's the same thing we're going to be doing down here. Only the number that we're carrying down is a 0. So you take out a negative 2. 60 divided by negative 2 is negative 30. We'll do our steps to that 30, which is to divide it by 2, which is 15, then to square it. 15 times 15 is 225. So we'll add a 225 and we'll subtract a 225. You see how easy this is, this completing the square? It just takes a couple times that we got to practice it. At the end there's a 0. I'm just going to keep bringing that down there so you can see it. Now we're going to take that negative 225 out, but before we do that, we got to multiply it by the gatekeeper, that negative 2. Okay, so we're left with x squared, 30x, a 225, and negative and a negative, so that's a positive, 225, so 225 is 450 if I've got 2 of them. And then we can do our last step, square rooting, sine, square root. And we know that our side lengths should all be 15 meters to produce a total maximum area of 450. So then you would write a therefore statement, therefore all the sides need to be 15 to produce a maximum area of 450 for this 3-sided fenced-in garden. Once again, this is completing the square for Unit 4, Lesson 2.